This is Eureka Grade 6, Module 1, Lesson 15, a synthesis of representations of equivalent ratio collections. I'm going to enlarge this so we can read it a little clearer. For our exploratory challenge, it reads, at the end of this morning's segment, the local television station highlighted area pets that needed to be adopted. The station posted a specific website on the screen for viewers to find more information on the pets shown and the adoption process. The station producer checked the website 2 hours after the end of the broadcast and saw that the website had 24 views. 1 hour after that, the website had 36 views. Exercise 1 is asking, create a table to determine how many views the website probably had 1 hour after the end of the broadcast based on how many views it had 2 and 3 hours after the end of the broadcast. Using this relationship, predict how many views the website will have 4 and 5 hours after the end of the broadcast. So before we can do anything else, let's go back to the broadcast and see what the producer found and the information that he gave us so that we can write it out. So it looks like here it says the station producer checked the website 2 hours after the end of the broadcast and saw that the website had 24 views. So I'm going to say 2 hours. There were 24 views. And then 1 hour after that, which would make it 3 hours. And then it said it had 36 views. So let's just write our information down first and foremost. Okay, so now we're asked to create a table to determine how many views the website probably had starting with 1 hour at the end of the broadcast, based on how many views it had from the 2 and 3 hours, the information that we have, and then figure out 4, 5, and 6. So the first thing we have to do here is draw a table. Okay, so here's my table. I've labeled it hours and views. And to start with, let's put in our hours because it says we need to start with 1, and they've already given us 2 and 3. Let's go ahead and fill out the rest, 4, 5, and 6. And then for views, well, if 2 hours they told us it would be 24 views. And for 3 hours it was 36 views. So our job is to figure out the rest of the table. Some may already see that it starts from 24 to 36. You can add, and going down you can figure that out because in hours it goes down adding 1. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. But they want us to later on come up with an equation. And so for that we want to think about our multiplicative properties. So we want to think about going from 1 to the next number by multiplying. 2 to 24 by multiplying, 3 to 36, etc. So we want multiplication to be our way of figuring things out today. That being the case, let's now look at what we know about 2 times what gives us 24. If you know your multiplication table and you're pretty comfortable with that, you'll know that it's 2 times 12. 3 times 12 also. So therefore, it stands to reason that our pattern would continue by multiplying by 12. So right now, go ahead and fill in the views based on what you know in your multiplication table of 12. Okay, hopefully your table looks like my table does, with 12, 24, 36, 48, 60, and 72 for your hours. Exercise 2 is asking, what is the constant number C that makes these ratios equivalent? So what number did we continue to multiply? The word constant and our C are our hints that we continue to multiply each one by to get the other. In this case, it was by 12. Okay, so let's look at the next one. Right below it in exercise 2, it asks us to write an equation. Represent the relationship between the number of views, V, the number of website received, the number the website received, and the number of hours, H. So views, they want us to use the letter V, and they said little v, but I'm going to use a capital V, okay? And hours, they want us to use H, and they had a lowercase h, but since I wrote mine in capital, I'm going to use a capital H. So I don't have space below mine. I'm going to write it here. To find the views came first, so that's the one we're going to think that they want to find. How did we get the views? What did we do to get the views? Well, it looks like we multiplied the hours by 12 for every single one of them. All of the hours, each one of the hours was multiplied by 12. We know, however, that that is not how we write things nowadays. You were taught this week that the way you write is not the hours times 12, but rather views equals, and we write the number first and then the letter. And we don't have to write anything, any operation in between, because when we have a number and a letter, it means multiply. Additional information is that that number 12 has a special name now. It's called a coefficient. And that letter H has a special name also. It is called a variable. So when you have a variable next to a coefficient, it means multiply. Okay, let's go on to exercise 3. Exercise 3 is asking us to use the table that we created in exercise 1 to identify the sets of ordered pairs that can be graphed. They want us to come back here to this and look at our table and write ordered pairs. Now hopefully we can remember that ordered pairs are written with an X and a Y inside parentheses. The X is always going to be on the left-hand side, the Y is always going to be on the right, and so our first numbers will be, in parentheses, 1, comma, 12. Our second numbers, our second ordered pair, would be 2 and 24, and so on. Your job is to go over to exercise 3 and write in the ordered pairs. And so here's what your ordered pairs should look like. 1 and 12, 2 and 24, 3 and 36, 4, 48, 5, 60, and 6 and 72. So let's move down to exercise 4. Exercise 4 asks us to use the ordered pairs that we created to depict the relationship between hours and numbers of views on a coordinate plane, which we just did last week. Label our axes and create a table for the graph. And then it asks us a question, will our points that we plot lie on a line? So let's start by labeling our axes. This is X, this is Y. Our x-axis, we learned over here, is the hours, and our y-axis are the views. Now, as you can see, I have color-coded them because I like to color-code things. I'm kind of crazy like that. Okay, so the next part, and we also need to have a title. So our title for this, let's just call it views per hour. Okay, so if we're going to then plot our ordered pairs, which is what we do when we're putting on a coordinate plane, we call it plotting, we're going to need to have some numbers here. So hours are pretty basic. They go in increments of 1. So we're going to write 1, 2, 3, 4, 5, 6. Let's go as high as 8. Now for our views, here's where it gets a little weird. We have to decide what we want our increments to be. And we need to make sure that we can fit all of our data points onto this coordinate plane. And so if we did it in 1, our data points would not go as high as 72. But we could pick another number. Some might want to pick 12, but then our coordinate plane becomes very small and kind of stuck together. So what's suggested is that we do increments of 4. So that would be 4, 8, 12, 16, 20, and then so forth. Why don't you go ahead and do yours, and then I'll do mine, and we'll check back. Okay, It's hard sometimes to squish them in. You have to write really small to really be able to read them, but I think we've done it. And so the next piece is to plot our ordered pairs. The first one, and what I've taught you last week, is I always say go in the elevator before you go up the elevator, or even before you go down. You always have to go in. So if we went in first at 1 and went up to 12, we would have our first one right here. Our second one would be at 24, which is right about here. Our third one would be at 36, which would be right about here. Our fourth one, and go on. You do yours, and then I'll do mine and check back with me. Okay, so hopefully yours looks similar to mine. It's hard again on a small one, so to really get it in there, your eyes play tricks on you. The question is, do the points you plotted lie on a line? And the question hopefully is that it looks close to a line, and yes it does. If you had a ruler, you could put a ruler through each line and try and get closer to the line. Okay, moving on to exercise 5. Exercise 5 says predict how many views the website will have after 12 hours. Use at least 2 representations. For example, a tape diagram, a table, a double number line diagram to justify our answer. So we could go back and do the table just by extending your table, and that would help us figure out after 12 hours how many it would be. I'd like to try doing it with the tape diagram because we haven't worked with that in a couple of lessons, and also a double number line because we didn't do a lot with that before. So to do a tape diagram, we would need to start first off with the ratio, and the ratio would be hours to views, because we're working under the same problem here. Hours to views, and our hours to views was 1 hour to 12 views. That's what we started initially. That was our value of the ratio. That was our initial ratio. And so we would need to do a tape diagram that shows 1 hour and 12 views. That would be 1 box and then 12 boxes. So let's do that first. Okay, so here's my tape diagram. Based off the ratio, I have 1 box for the hours and 12 boxes for the views. Let me see if I counted them right. Yes, I did. So our question was, predict how many views the website will have after 12 hours. That's the extra information that they give us when we're writing a tape diagram. That always helps, and that goes on the end of hours, and that would be 12. So if they gave us 12, and there's only 1 box, so that means inside the box goes the number 12. That's our constant. And of course, remember the rules for tape diagrams. What goes in 1 box goes in all the other boxes, even below. So 12 goes here, 12 goes here. And then all we have to do is figure out the number for the end. And that should be 12 times 12, which is 144. Okay, so let's see if we can find the same information by doing a tape double number line. First, we'd start with our first number line, which has to do with our hours. So we draw a line. We'd start at 0. We'd label it hours. And we would write 1, 2, 3, and so forth. Go ahead and do yours. And so our hours will look a little bit like this. Now, if we're going to do the hours, we have to do the other side represented, and that's views, and that's done with a second line, hence the word double number line. So I'm going to extend my lines here. This might not be the prettiest double number line ever. I'm going to do another number line, and it already has the lines because I just painted them, and now I just need to put the numbers. So this would have been 0. This has to do with views. After the first view was 12, second view was 24, 36, 48, yep. Okay, you finish it. And so this one is pretty easy. We didn't have to do anything in between. We just extended it. And so we would have come up with, in 12 views, it would be 144. In 12 hours, it would be 144 views. And so that is exercise 5. Let's take a look at exercise 6 and 7, which I would like you to do on your own. Okay, this is exercise 6. It says, also on the news broadcast, a chef from the local Italian restaurant demonstrated how he makes fresh pasta daily for his restaurant. The recipe for his pasta is below. 3 eggs beaten, 1 teaspoon of salt, 2 cups of all-purpose flour, 2 tablespoons of water, and 1 tablespoon of vegetable oil. Determine the ratio of the number of tablespoons of water to the number of eggs. So first and foremost, you need to write your ratio out. And then, provided the information in the table below, complete the table to determine ordered pairs. So you are to complete the table, tablespoons of water to number of eggs, and use the ordered pairs to graph the relationship of the number of tablespoons of water to the number of eggs. So your job is to make your own graph, your coordinate graph. See how you do. Down below it says, what would you have to do to the graph in order to find how many eggs would be needed if the recipe was larger and called for 16 tablespoons of water. So that's what we did back in lesson 14 when I started over at 16 and I went over to the line that we made. So I would suggest you draw a line in this one so that you can continue it to tablespoons of water. And just to give you some help, let's call this one a pasta recipe for your title. And our x-axis will be the water down below. And so we'll have the water, and then you want to put your numbers in there. And if you can't fit the word, because my numbers are going to be kind of squished if I try and do it in here, you can write really tiny or just put the W for water, and then eggs goes on the side. And eggs you can have plenty of room to write. For your increments on the bottom, of course, you want to make it number ones, so 1, 2, 3. And then for your number of eggs, I would suggest that you go ahead and start with increments of 3 on this one. 3, 6, 9, okay? And then on your graph, show how many eggs would be needed if the recipe called for 16 tablespoons of water. So the question is here, but you can actually answer it right over here. All right, so that's exercise 6. You can do that on your own. So exercise 7 continues that exercise 6 and says, determine how many tablespoons of water will be needed if the chef is making a large batch of pasta and the recipe increases to 36 eggs. Support your reasoning using at least one diagram you find applies best to the situation. So that means you get to choose. And explain why that tool is the best to use. Just like our wrenches, you get to pick the wrench that you like the best. So the wrenches or the tools that you have to choose from would be a ratio table, and so you'd have to rewrite the ratio table again, the tape diagram, or the double number line. All right. If you would like to add in another way and you'd like to have extra credit and do the equation, that would be fantastic too. So let's see how you do. We will talk tomorrow. And please remember, when you do this today, to take a picture of lesson 15, or several pictures of it, and upload it into Google Classroom so that I can give you credit for completing this assignment. Thank you.